Welcome to the Explainer. If you're a focused learner, ready to master your system's performance metrics, you're exactly where you need to be. Today, we're going to completely demystify the Unix installation process for SPEC CPU 2017. I know setting up benchmark suites on environments like IX, Linux, macOS X, or Solaris can feel kind of daunting, right? But hey, we're going to tackle this together with a crystal clear, step-by-step command line walkthrough. By the time we wrap up, you'll be navigating this install like an absolute pro.
Here's our roadmap for the day. First, preparation and prerequisites. Second, mounting the ISO image. Third, running the installation script. Fourth, configuration and environment paths. Fifth, compiling and running benchmarks. And finally, number 6, alternative installs and uninstalls. Let's get right to it.
Starting off with Section 1, Preparation and Prerequisites.
So, before we start firing off commands, let's talk setup. You'll definitely want to verify your system's physical memory and disk space for the specific benchmarks you're planning to run. But really, the main thing here is that you need some basic familiarity with the terminal window and standard Unix shell commands. You know, the classics like ls, man, and mkdir. If you haven't already, go ahead and pop open your terminal window so we're ready to roll.
Now, a question that comes up a lot right off the bat. Once you download that massive ISO file, is it okay to skip the SHA 512 verification? Well, officially, it's highly recommended to verify the checksum against the SPEC website just to make sure your download isn't corrupted. But honestly, if you don't feel like hunting down an SHA 512 tool right this second, skipping it is probably fine. The installation script has its own built-in safety net and will actually verify the individual files later on anyway.
Moving right along to Section 2, Mounting the ISO image.
Okay, let's dive into this. The whole installation phase basically boils down to 3 core steps. First, we mount the ISO image. Second, we change our working directory over to that newly mounted image. And third, we run the install script. Sounds super simple in theory, right? But the actual execution can tweak a bit depending on your specific hardware.
Mounting an ISO is where different operating systems really start to show their quirks. You're going to need to use the exact mount command for your specific setup. And here's a vital detail. Unless you're on macOS X, where a regular user can literally just type the open command, you're generally going to need root or administrative privileges to execute these mount commands on systems like Linux, Solaris, or AIX.
All right, on to Section 3, running the installation script.
When you kick off the install script, it's going to ask you for a destination directory. Choosing a safe path here is absolutely crucial. You literally cannot have any spaces in your destination path. Why? Because a lot of Unix programs treat spaces as argument delimiters. So, if you use a path like home/mybenchmarks with that sneaky little space in it, your installation is almost certainly going to fail or act super weird. Just stick to solid, unbroken paths like scratch/CPU 2017.
Now, during the install, the script is going to automatically try to select a set of pre-compiled binary tools that match your specific hardware and OS. If you're a beginner, don't stress if the toolset isn't a flawless 100% match to your environment. It honestly doesn't affect your benchmark scores at all, and the script runs tests to make sure the tools actually work. But if you're a power user who wants total control, you can absolutely override this. Just use the -E flag to exclude a specific toolset, or hit it with the -U flag to force the installer to try the exact one you want.
Once that tool set is locked in, the script stops bothering you with questions. It just puts its head down and gets to work unpacking and testing files. When this automated phase wraps up, you'll have used about 2.6 gigabytes of disk space on your destination drive. That's a good chunk of space, so definitely keep that number in mind to ensure you've got plenty of room before you even start.
Section 4, Configuration and Environment Paths. Oh, and quick side note, if you had to use root privileges to mount the ISO earlier, you can safely turn those off now. From here on out, you just need to operate as an ordinary user.
Now, what's really interesting about this step is how the path setup command changes entirely based on your specific Unix cell type. You basically have to introduce your current session to the SPEC CPU tools. If you're working in a C shell compatible environment like CSH or TCSH, you're going to use the command source cshrc. But if you're rocking a Bourne-compatible shell like sh or bash, you'll use source shrc. Nailing this step is exactly what allows your terminal to actually recognize all the spec commands we're about to use.
Next up, you need to select and edit a configuration file. You can usually grab pre-made ones straight from the SPEC website or find them hanging out in your installation folder. When you copy one over for yourself, the single most important edit you can make is to the label. As you can see here, a label is basically just an arbitrary tag you stick onto your binaries. Naming it something unique like first run, all one word, no blanks, is a total game changer. It makes tracking your work, finding specific run logs, and keeping your disk from becoming a messy nightmare so much easier later on.
Which brings us to Section 5, compiling and running benchmarks.
Look, before you commit to a massive multi-hour full run, I always tell people to start small. Try compiling just a single quick benchmark, maybe 505.mcf_r for spec rate or 619 lbm-sis for spec speed. This quick little test just verifies that your configuration file is actually pointing to your C compiler correctly. If it works, you'll see an executable pop-out featuring that label you just picked, and you should also verify that a log file, like cpu2017.001.log, has magically appeared in your directory.
Navigating the insanely complex directory structures of SPEC CPU could definitely feel a bit overwhelming. But luckily, when you sourced your environment paths a minute ago, it set up a super powerful utility called the go command. You can use commands like go build or go log to instantly jump to the right directories without getting lost in the weeds of your file system. Trust me, it is an absolute lifesaver.
Once you're confident your compiler is working, it's time to throw a brief test workload at an entire suite. Let's take the command run CPU --no reportable --iterations equals 1 intrate. This is strictly a test run. It takes the absolute smallest workload size for the integer suite, runs it exactly once, and explicitly tells the system, hey, don't even try to make this a full reportable run. Depending on your rig, this might take 10 to 15 minutes, and it's basically the perfect final sanity check.
If that passes with flying colors, you are ready for the real deal. But wait, first, you have to configure for your multi-core processor, and this brilliantly illustrates the key difference between the two main benchmark types. If you're running a spec rate benchmark, you measure throughput by setting the number of copies to match your system cores. On the flip side, if you're running a spec speed benchmark, which measures how fast a single task completes, you need to configure the number of threads instead.
All right, here's the command for the final full reportable run. In our example here, let's say we're on a laptop with 2 cores. We'd type run CPU --copies 2 --reportable intertrate. Notice how we swapped out those test flags for the reportable flag? A base-only tuning run like this for 2 copies could wrap up in less than 3 hours. But be warned, if you add peak tuning or ramp up the copies, expect that time to shoot up significantly. Honestly, it's the perfect kind of thing to just let run overnight.
And finally, Section 6, alternative installs and uninstalls.
So what happens if you just straight up don't have root access on your target Unix system to mount the ISO? No worries, you can use the tar file fallback method. You essentially mount the ISO on a system where you do have access, like your trusty Mac or Windows laptop. From there, you extract 5 specific archive and tool files, like cpu2017.tar.xez and spectar. You transfer those files over to your target system, unpack them manually using the tools provided rather than your system's default tar command, and then simply run install.sh exactly like we did back in step 3. Pretty neat workaround, right?
Wrapping things up, when your benchmarking journey is complete, you're going to want to clean house. Now, a word of the wise. SPEC CPU 2017 does actually have a file named uninstall.sh, but here's the catch. It only removes the toolset, not the massive benchmark files. Since SPEC doesn't give you a true full uninstall utility, you have to manually use the remove command. Just type rm-rf followed by your installation directory to wipe out the entire installed tree and get all that precious disk space back.
And there you have it, the whole shebang. You are officially installed and running. But before we go, this brings us to a really compelling final thought. Now that your basic setup is complete and humming along perfectly, are your system resources truly optimized to capture the perfect reportable benchmark score? Because honestly, installation is just step 1. The real magic lies in diving into those configuration files and tuning your system to its absolute peak potential. Until next time, keep optimizing and happy benchmarking.